ya wa lu she da shina ya lu she wa ku mo ka to chi hong kan na ni to khia mi ji bu sa ka ne khia mi ji sa ja a ni mo da chi nya da ho the ni te la tong le ya da chi se ya da ko cha pe la mi chi fio nya to lu she da shina. Good afternoon, Phil.
Hi, Sam.
Hi, thank you for this opportunity that I'll be able to see what you're doing here. I would like to ask you to tell us a little bit about who you are, what you do.
Thank you. So today we're at Reedley College, and I'm here with Rafael Ortiz, Ken Grimes, Sam Vang. I'm Phil Smith, and Rafael and I, we're soil scientists with the USDA Natural Resources Conservation Service. We're with the Hanford MLRA Soil Survey Office. And our area of responsibility is pretty much the Great Central Valley. We cover everything from the Grapevine all the way up to Redding and even some parts of the mountains. But we're here today to judge 4 soil pits for the California FFA Soil and Land Judging Contest. Now, this is a local contest where high school FFA students will practice their skills and compete, but this is really like a practice for the state competitions, which there are 2. One will be at Fresno State, and the other will be at Cal Poly, and the schools will weigh those scores equally between the Fresno contest and the Cal Poly contest to see who will be the championship team for soils and land judging.
So what's the purpose of that, Phil? Can you tell me a little bit about the students?
Yes.
Or what they're doing there?
So the students will evaluate a soil profile like this for the physical, mainly just physical properties that they can observe by picking into the soil with a knife and texturing the soil, as well as reading soil colors. And they will use the definitions and standards that are defined in this manual. And so they should be familiar with this manual, and using these standards and definitions, they fill out a scorecard.
Right.
Okay, so today Rafael and I were describing this soil, and this will be the answer key for the contest in 2 days. So one thing that we found here, we call it about a 7-inch layer of topsoil. So the terminology is kind of simplified for the purposes of this contest. So we're saying there's a 7-inch topsoil, and you can see changes in soil structure here. You see how there's a granular soil structure here and a darker color than there is right below, and there's a greater root density. But you can clearly see differences in structure from here to here, and color from here to here, and a greater density of roots. So seeing this kind of structure, and the texture is a sandy loam, this kind of soil will have a good infiltration and good permeability throughout, all the way really until you hit a durapan or hard pan at about 48 inches. And we are on a high terrace here above the Kings River, and you can see out there that it's the Kings River. We're a good bit above the floodplain, and there used to be an old soil here, and that's evidenced by a durapan, silica cemented hard pan that's at about 48 inches, and above here is this is all an aeolian deposit. That came along after a lot of geologic erosion had happened and removed an old soil, exposed this hard pan, and now you have this aeolian material in which this soil has formed. So for this contest, we go through here, we describe this 7-inch topsoil, subsoil, really down to 48 inches for the new soil, and below that is a durapan of the pre-existing soil. So really we have a change of strata right there at 48 inches.
I see.
And so as we go along through here, we said we had a 10YR53 and color book. So we use this color book, this Kawmntawv color chart, to help us determine soil colors. Colors are important. We can estimate, is there a lot of organic matter?
Oh, okay.
A darker color, higher organic matter. Grayer, low chroma colors oftentimes indicate wetness. Brighter colors usually indicate, good drainage. So anyway, we have these chips so that the color can be described very precisely to a hue, value, and chroma. Each page is called a hue, and values are each row like this, and then the chroma. So a 10YR 5, 6 would be this color.
I see.
So that's how we use this color book. So we go through the horizons here. This is kind of simple. We're going to have a topsoil and a subsoil. We do the colors. We look at gravel content. As I said, this is an aeolian soil, so there's no gravel here.
I see.
This is all wind-blown deposits. And we're saying this, we have an 8-inch topsoil. We have down to 48 inches. We have this subsoil, and then we have a Durapad below 48 inches.
Right.
Sandy loam. It's actually a fine sandy loam. And as defined in this manual, we have a very thick topsoil.
Wow.
There's a hard pan. And this all goes into the interpretations for evaluating the soil. We want to say this is in loose or mixed material. That's the parent material of this. Deep is the depth of favorable roots and water penetration. It's 48 inches. Air and water movement based on texture of fine sandy loam is moderate. And we also use texture to estimate available water holding capacity to 60 inches. So here we calculated that for a fine sandy loam to 48 inches because we're not counting anything below that indurated hard pan.
Right.
And we have about 7.2 inches of available water holding capacity.
So is this an irrigated land, or is it non-irrigated?
We are on non-irrigated land, so we're taking that into consideration for how this land can be used for land use, and that's part of the judging contest. We saw some real erosion over there. We're on about a 20% slope, and we use that to determine what categories of erosion are here. We also look at where we are on the landscape and determine what landform we're on. And here we're on a terrace. Right. I'm actually calling this dune land over on top of a terrace, as we have aeolian material on top of that old eroded terrace soil with the Durapad. We're kind of on the break of where the terrace tread and the riser, so that's where we are on this slope. And using this information, we have put this into a class 4 category of land capability class. And it can be used for non-irrigated crops, range, and wildlife recreational watershed. Major problems in use, we have 8 choices. Here we've chosen erosion, slope, and a hard pan, even though, as you can see, that's very, very deep, so that's probably not really a concern, but just going by the book, we've put it on the list. And land management needs, we've checked erosion control, fertility improvement practices, and grazing management. We didn't check chiseling and ripping, just because that's just so deep down there. We have plenty of room here for plant roots.
I see.
Erosion control practices, vegetative cover and mulches, and contour farming would be applicable here. There's no water, so there's no irrigation method checked. And then we have urban land limitations. We have these interpretations. For septic tank absorption fields, severe, most limiting factor is slope. Shrink swell potential, we put slight because we have got a medium texture here. And foundations with basements, local roads and streets, and topsoil all have severe limitations, and slope is the limiting factor.
All right. Thank you.
Thank you very much.